Yeah, so now what we'd be ready to do is to go to my assembly file that I have that I've created from here, which is this one. It should be screaming at me to make updates with my lightning bolts. I just come up to my quick access local update here and accept that. Oh, see, mine blew up on me kind of weird. Like, I don't know if I've not saved my part right, but I've lost an edge of mine. I don't know why. I got to come in and see what I've done here. Oh, I just don't have my bend is still malfunctioning from when I was playing around earlier, so I just need to edit this and choose this. Say okay. And I'm going to jump back over there. So that's what you do. I mean, that one is driving, and then update it, accept it, and that seems now my parts seem to be happier in my actual assembly file here. So you should, when you do those updates, you should end up with a flange there on that now. We should end up with those cuts in the side, the relief cuts that are kind of, and we should end up with something that doesn't have a huge hole in the side here, but maybe still has excess material. Oh, yeah, let's see. So your output chute is gone. Like this whole thing, the whole main housing.
No, no, no.
It's actually not. So because probably because we changed your thickness order a little bit, huh? And I think um okay, so I think if your thing totally blew up on you and is no longer here, I think come back to here and do come back to the come back to this one, sorry, your one with your derived part, and do a make components again with that new chute. So you come in here and you say make components, select the target assembly as the one you already have. So you'd be like selecting do you want to create a new target assembly? No. And then you go in and find that assembly as your target assembly, like here, which is in my only assembly I have in my assemblies folder. So that's going to be your target. And then you're going to select that part again. And then say next. And then give it the same name as the one that it should have been before. If you can identify what that name is, because it'll override it essentially. I wouldn't want to, I don't want that other one to even exist. If it blew up on you, you'd want to like, go to that source path to send this one to your parts. You just select the one that's blowing up on you because your other ones are fine. They're showing up over there just fine. So you're only trying to like almost resend that other one. And what I would do is give it that same component name here, send it to the same file location, which should be one of those new, I don't know which one it is for you necessarily, but try to identify which one, and from your model that doesn't have it yet, you can go and see from the parts lists in that model which one it should be the name. And I think if you try to rename it the same name, it's just going to give you a prompt that says, "Do you want me to overwrite that part name?" And you'd say yes. Let me know if that works. Yeah, I would like it because while you're in this command, I don't know if you can jump over to. I'm still in the command and I jumped over to this. Can you identify it from the created assembly, which one it would be? For me, it's SC007 is my number. Because yours in this assembly where it disappeared, does it still have it there? Is there only two parts there now? Yeah, you can close it and go. Is there still three parts? That one is missing, right? Yeah. So you want to choose that file name as the one you're kind of overriding. I kind of should see if this works, but I think it does. I think I've done this before. Select your assembly. Just really just selecting the folder where it goes, I think, is all you're doing there. It's going to show it. It's going to go in that folder. And once you select that folder, if there's one with that same name, it should give you a prompt and then that component name is what you want to change to that part name. It's just that the name, you want to make sure it's that one right there is the one you change, right? under the component name is where I select and I type in my name that I want it to become. That's going to be the part name. Yeah, so it's got to be the one that matches their missing one. Was it six you said or something? I'll wait to see if that works for you. So it won't let you override it in that. Okay, so it does, and that part isn't open. So it gives you this big, like it can't do that. Okay, I think if you, interestingly, probably if you close the assembly that the next thing I would try is just to close the assembly file because it's technically it's open in that assembly. If you think of that, yeah, like you'd want to like close that. It might ask you to save before you do or not save or whatever. You probably want to save it before you close it. It's going to save all those files. Yep. And then try to do that one more time because technically it's not open now. And then sometimes if I have too many errors, I'll be like, it still says no. And then it opened that file, right? Bam, it's there. Yeah. It's a file naming nightmare sometimes, right? It's like it shows that you, yeah. No, it's good. That won't be the last time we have to do that, but it is tricky. Yeah, yeah. That's that. I mean, that's a good thing to notice. If you ever, if your parts ever disappear on that target assembly, you may have to close it all up and then go back to this assembly and resend it. Give it, So yeah, potential. Now there's two of them there. Maybe delete the one that you don't want. So it did send it, but it also kept the. You should be able to delete that one out of there though from there. Yeah. Interesting. Yeah, yeah. Is there two in your, you should open up your parts and just make sure that there isn't one that has like a little :2 around it or something. I mean, generally with just updates, you should have been able to, yeah, okay. But that's all I wanted to get was to here. Now I want to check. I have those three parts. I just want to so I have my assembly open. I just want to open each part and make sure that they're updated. So there's that part. I think I'm going to go to my flat pattern and just check it. So if you're checking your main housing, it should look like this now with my slit cuts there that are going to help me bend that actually. That's critical to have a relief cut in order to bend those flanges out of the same part. The other interesting thing here to note as somebody that doesn't know, haven't hasn't if you haven't worked in the industry a lot, it's a good to be aware of what is the size of this piece of sheet metal. Is it even sourceable? I know that I've designed it to be one piece, but you can, double check yourself on your flat patterns here and say that this thing is 96 inches by 34.68 inches. So you have to, like when you make flat patterns, especially large flat patterns, you then need to like quickly in your design process decide if you are designing to use sheet sizes that are available or if you have made stuff too big. And then you have to go into your design and then decide where to put seams then if the part was, 15 foot by 72 inches. Well, I'm not going to make them buy a piece of sheet metal like that. I'm going to have to determine what my manufacturers can build with, what size of sheets we might have on hand, and what we regularly stock, and design with those constraints in mind, right? And this is what new people to drafting really struggle with, and new engineers do as well. They just are not paying attention to what materials we use at our company and what we can get instead of getting special size sheets and then designing around those constraints. Here, I mean, I've just got to be able to get like an 8x4 sheet which is a really common size. So I'm well within the like a normal size piece of sheet metal. But you have to pay attention to that. Otherwise, I mean, that's one of the biggest ridiculing thing I would see come from like manufacturers, from and their feedback to design and engineering was like, yeah, go ahead and design parts we can't even source, right? And that is a huge problem. So, it does make you have to be cognizant of that while you're designing. And there are times when there are specially sourced things that I need to get. And I need to recognize that early on in the design process and get purchasing to get the lead time. The most lead time they can get to order materials, the better. And then I design under those constraints and pay attention to it as I go, rather than figure it out you've already spent months designing, you send it to production to produce. Now they've got to spend 6 weeks waiting for the material to show up. You try to use some of your design and engineering time, give purchasing and manufacturing as much time as you can to order long lead items, which is special size sheets, which is sometimes equipment, buyout parts. Strangely, weird things have long lead time. And yeah, and that's that. So I'm just checking this. This is great. That folded part works good. This one here, I'm going to open it up. I've defined my A side as this side here is kind of the outside of the chute. So there's my flat pattern for that. Has a little bend on it now. Cool. Those show the center of bend plus the bend extents is what you're seeing, three lines around every bend, right? It's kind of the bend extents and the center of bend. And then the last part that I have was this one here. I just want to make sure that I've defined this A side is here. Oh, my A side doesn't show up. So what I'm going to do is, and I've got a blown up flat pattern. Go to flat pattern. I'm not sure why. If your flat pattern has blown up, just delete it because we haven't really used it yet. I'm going to say, okay, delete that flat pattern. I want to redefine the A side definition. So I'm going to delete that as well because it isn't showing that it knows what A side is anymore. And it's just because I've changed this part pretty substantially. So I'm going to delete the flat pattern, delete the A side definition and redefine it. Because before I make a flat pattern, I always have this habit of making an A side designation, define the A side. This is the outside of my chute. And so that's what I want is the A side. And I'm going to create that flat pattern. It says that I have an overridden rule. Like I've got something maybe turned off. Like, let me see here. It actually, that's one reason why I create the flat pattern. It says I can't. I need to go back and see if I've got something suppressed or something. I've got some problem making this. I don't know. I don't exactly know what it is. And you guys might now too. So technically it's a solid, like in the individual file, it is yeah, it could be. It could be. Or it could be like some people aren't having issues. And well, I think what I've got going on here is I've got a suppressed bend here, potentially. Like I've got something going on with a bend in mine. You may not. It's just that maybe I missed something here that I did. I've got my thickens, which should have joined those together. And then I've got this one bend that for some reason is showing up as kind of suppressed. And I don't know why. What other bend do I have? I have that bend. This is why my flat pattern's not working for sure. I think it's because of this bend is grayed out on me right here. So I've got to determine why that is. Or I could try to delete that one and reapply it. That bend is now misfunctioning. Mine is kind of acting just a little bit weird. And if yours is not, that's good because originally yesterday I wasn't having too much issue with it. Let me see. You're getting that as well. So I'm back to my original part here and I'm troubleshooting it just a little bit like this. Like come back to this and see if you've got like I've got a grayed out band. I know I'd have grayed out thickenings because those should technically have taken on and overridden those separate solids. But this bend should not be grayed out. That definitely is causing a problem. That should be an active bend. And I'm just going in to edit its feature. Maybe I'm going to reshift select the edges. Like I'm gonna actually shift unselect them and then maybe reselect them here. Well, it's just grayed out on my. It's like not blue. Like the icons that are active are all like blue. Okay, but it's still not working. You should have a couple of thicknesses grayed out for sure. Mine does act weird. Mine acts weird the way it could be the order that my thicken here. Is that thicken? That's that one. This thicken. I kind of wanted that thicken to be the one that stayed and to join these other two. Hold on a minute. Let me think about this for just a second. I'm going to come up to this thicken. We go to bend one. Is that one? That's my first thicken. It joined to that with this bend, which should allow that to happen. Hold on just a minute. So I am reorganizing mine a little bit. And then I went to thicken A. So I did a thicken here and I did a thicken there, and then I did a bend. And then I'm going to say I'm going to do a thicken here, and then I'm going to do this bend. Accept it. It doesn't like that second bend for some reason. I'm going to edit the feature. I'm going to reselect my edges. Edges. This one to this one. Okay. That is happier that way. And then I should have applied the cut in the other flange. I'm hoping this works. Now my bends are both blue. I definitely have my thick. So I've done a little reorganization of parts. Let me see if this worked for me. If you're having this issue, I mean, it's so particular sometimes. I'm back to here to accept those updates. And then it should have updated this part as well, which is my number 7. Number 7 part has an A side definition. It doesn't anymore because I've kind of changed it. I'm going to delete it. Redefine my A side. You can't redefine an A side unless you delete the flat pattern. Oh, mine still can't do that actually. Interesting. I may still have an issue here that I wasn't anticipating. And you guys may also. I don't. So is everybody having issue with their flat pattern on that? Some people got it. Interesting. That is interesting. This is the nature of this game. Like doing the same things, we get different. I don't know why that is on mine. Let me see. Use yeah, use set sheet metal rule on the body and ensure that it adheres to the default sheet metal settings. This one should be 12 gauge, like it's coming default by sheet metal rule, stainless steel. That's material. Let me set by sheet metal rule here. I'm just in the actual individual part on its. Well, I think I could probably figure this out. I don't know why though. I don't know why. Yeah. What? in this part. The only thing I changed really was my bend relief width, which really isn't kind of affecting that. Yeah. No, it could be a little different for everybody actually, but well, interesting. Interesting. That part has kind of been, yeah, that's my only sheet metal rule that I really have. It's kind of interesting. Um, yeah, that one flattens out good. My other one flattens out good. This is my only, my only difficult thing here. And it could be how this is cutting for sure. It could not like that way. I'm just going to do a little mini experiment on mine and adjust my cut a little bit. Oh, I do have this as all. I don't know when I ever changed distance to be that. Interesting. I don't remember. I don't know if I thought I only had thickness here. Okay. And I've tried with thickness. Anyway, I kind of had a weird cut setting on mine for some reason. Still will not flatten out. So I never I could maybe need some troubleshooting here. I might have to do some, and it could be that, yeah, maybe I don't remember this being a problem though. I've done what I'm doing before and not had an issue. So, but yeah, I am suspicious that maybe it doesn't like that for some reason. The way that I've chosen to join I only have three solids. Solid seven, thicken, bend, cut. I'll do a little, I keep doing a little troubleshooting here since I've decided to nerd out over this a little bit. Let's keep going. My nerding out. See if I can mess around a little bit here. Trying to decide what I want to do here. This will be a silent video here. That's my original one here that I didn't have issues with. Yeah, it doesn't like that. Doesn't like me to add bends like that. Hmm. Well, I'm probably just trying to do something that's not no good. I hate to continue too far on that part without it being kind of correct where I want a flat pattern for it for sure. So I definitely need to spend. And I want it to be in one piece. This still might, okay, so I'm playing around one more thing here. Let's see what, I don't want to say too much yet, so it's if I get something that works, I'll start talking again. Back to here, update that. Back to here. It doesn't like either way. It doesn't like it if I don't. Noticing. 'Doesn't really affect an update here. Okay, stay tuned for that one. I'll troubleshoot it a little bit more and see. I've tried it a couple different ways and I haven't got it to be totally corrected. I've tried by not making new solids and then still bending them later doesn't help me much. So see right now I don't have any of my thickens that are not still active because I made them as joined solids, but they didn't create that natural bend that the first time we were doing this did. It allowed me to add a bend secondary, but I'm not so sure that it's not causing me problems just because it's not cutting through the bend correctly. Actually, I just I don't know. I'm gonna play around a little bit here and see if I can get that part to cooperate. So stay tuned on that. One problem creates another problem. That's normal. So so we'll just stay tuned on that. If it works for you, good. I'll get the others to work, I promise. These kind of problems, like I can't sleep at night. So yeah. And it's taken a while just to get these. And so I'm ready to kind of, yeah, come back to it. I'm not going to get rid of it. Just leave it how you've got it, and that's fine. If it won't flat pattern, I've just got I got some things I got to work on. And so at this point, though, what I want to do is like let's start some drawings and start putting some stuff on a drawing at least. And then we'll make some other parts to send to this assembly as well. So what I'm going to do here is I'm going to turn on, like for me, I'm ready to kind of save this as it is. Like I'm not totally happy, but I've done some exploratory work and I've still got some more to do. I'm going to turn on my planes here. I'm going to save this as my assembly part so it looks like that in my folder structure. I'm kind of done working with it for a minute. I've made some improvements that I'm happy with. I've got others to work out. This one here is my main assembly. I'm just going to make accept its updates and go ahead and save it. It'll always be saving downstream from it. So it's going to save itself plus the parts that are in it. So I'm going to say OK. That's a way to save all your parts. So that actually does a save on all these individually. And now let's go ahead and open up a drawing set. Um, Repost that here. Yeah. So I'm going to say that let's get some stuff on a drawing. Let's get that started. Um, I'm going to say in our courses here, there is a template there's a new template you can download. I don't think I've made adjustments. I haven't done any adjustments since before spring break. So if you've probably downloaded it before spring break, I just don't think we've done many drawings since in this 8 week block yet here. So except for maybe on your car. I don't know if anybody started their car drawings yet, but that's another thing to start. So I'm in our course here and gonna make sure you download just the new template files. They'll be in the resources for 1138. I think the only thing I really have there is template files for Inventor and still CAD files there too. But we just want that Inventor inch B size template. So make sure you've downloaded that. I'm gonna go ahead and open my template in Inventor. So I'm going to open my template file, which I have saved where I usually save it in my general area, I think. Yep. I think this is still living in the previous lab. We have our B-size template now. I'm going to save this as I'm going to save this as my main assembly. How am I going to do this? Yeah, I think so. I'm just going to save this with my main assembly. This is currently my main assembly. SC 100 for me. I'm going to save my drawing with that name. It's going to match. It's going to match SC 100. What do I want to do on my drawings? Drawing number. I think so. I think I'm gonna build everything out from here. It's going to be the housing. It's going to be the housing assembly. Then I'll add everything else to it. So I think so. I think this is going to become my drawing name. This could definitely vary from company to company what your main overall drawing name is. And I can change it later, I guess. Not super easily, but I'm gonna save this as in my drawing folder. File, save as. It's gonna be in my 1138. Sorry, my screw conveyor for this year. Here's my drawings folder that I already created. I just need to give it a name. So yeah, I think I will. I think I'll call mine the name of that first ISU. Mine's MR SC screw conveyor 100. It's going to match that top level assembly. I think it's going to be I'm going to have other sub assemblies. that'll have different numbers. But I think I'm going to make my drawing match my kind of my 100 assembly name. And so this is going to be an IDW file in my drawing folder, so it'll allow me to do this. So this does match, going to be my top assembly. Whether that does or not for other companies is probably case by case basis, but I'm going to say save that. MRSC 100. Okay. And then what I'm going to do is I'm going to make some copies of this. This is a single sheet, but we're going to have a bunch of sheets for this. And so I'm going to go ahead and start. I'm going to make at least five copies of this right now. So in order to just to get this going here, this B size sheet, copy it here, paste it. Yeah, I'm just going to do this a bunch of times just to give myself some sheets to work with. I don't even care how many I do. I'm going to have probably more than 10 sheets here. So, I'm not necessarily going to be in this arrangement, but maybe close. So I've got like 10 copies of this sheet. And on the first sheet, I'm going to go ahead and load this assembly on it right here. The dot IAM assembly. So what I do is I'm going to take a quick look at it. I'm going to go to that like here, and then I'm going to jump back over to my drawing, and I'm just going to say place base view here. Otherwise, or you can select down from anything you've got open and select the one we want. But the one we want is the .iam assembly here. And I'll go ahead and have, this is the front view that I've designed with. I'm definitely going to want a right side view. It's huge, right? So we've got to scale this thing down. I'm going to want view labels. Yeah. I think I'm just going to do a front and a right side, and I'm going to do, I want the assembly. Yeah, I want my first sheet, and we got more we're going to add to this assembly, so it's going to grow as we go. I just wanted to get my drawing started. And because normally once I have things on a drawing, that is my driver of where I get to stuff. Like I put it on a drawing, then now my drawing is my controlling document. And when I go to open this project again, I'll probably go to the drawing, open it, and open these files from the drawing. That's kind of how I work from the drawing. Once I get a drawing, it's like drawing down. It's how I drive my access to these parts. But so, sometimes I don't make a drawing. Sometimes I don't make a drawing until I have a completed assembly to drop on there or whatever. We're not quite at a completed level yet, but I just want to get our drawing started because this is drafting. So I feel like I've put off drawings for quite a while now, and I'm just ready to get. And this will just grow as I build out. I mean, it'll accept the updates that I'm doing on the assembly as well, on right onto my drawing. And so it's not like I've got to go back and once I get them on a sheet. I'm just trying to think of what I want to show on this. It's going to kind of be the overall assembly, so it's going to mostly be some sub assemblies and some parts. Um, yeah. So I think I like this. I've just got to make it fit, obviously. Quarter's going to be a little bit big. I'm probably going to make this, I don't know, an eighth. How big is an eighth? Like that? That looks better to me. Like it might fit on my sheet. I can adjust that in a minute. Just putting a front view. I'm going to put this right side view. I may end up like doing a break in here and shortening that to fit here. And then I kind of this is going to grow pretty substantially though to where it might end up becoming that I eliminate my orthographic views and I just keep kind of a 3D view. In fact, maybe we can plan that actually. I think on this first sheet for this assembly, it's not going to have, I don't think I'm going to do the orthographic views of it. I'm just going to do an isometric view and something that I can uh, allow put parts descriptions on and call out sub-assemblies here. And so I think this is going to come down into a second sheet. So I think what I've decided is I'm going to delete these two views. And I think my isometric will be the first sheet of this assembly here. And I still need to make it so it fits. And it's going to grow out a little bit from here. So I'm just going to edit its, I'm an eighth of an inch scale. Oh, I don't know. What are we going to go? Like a tenth maybe? Tenth scale. And since I don't have the other orthographic views here, I'll add a view label to this isometric view, which we'll adjust that in a bit. So it might come over here and be something like this. This might even get smaller as we build this out and we have a big hopper here and some of the discharge stuff, but this is at least a good start for that. So I'm planning on this view being my isometric with callouts. So the next sheet down for me, and I can switch the orders of these later, so that's fine. Like I might not love the running order of my sheets, but I can move them around when I need them. And so I'm going to jump over to this sheet here, which is just a copy, my first copy of that sheet. And maybe I will place the orthographic views of this here now. So it's kind of going to be like a housing orthographic view here. So I'm going to still place that same just the same assembly, my SC, the only assembly I have. I'm just going to add that and add the right side view. And here, I don't think I'm going to add the top view. It doesn't really add a lot of detail. I don't think so. And I think I'm just going to do a two view. So yes, I did. I just went to an isometric only here. Don't, yeah, don't pull in the solid or or what I call is like that part assembly where you built. This is the assembly that was exported when I made components because that is the first assembly I actually ever have built. Yeah, it's a .iam for sure. So it's not this one. This one will never live on a drawing, actually. This is just a design control part, much like this is. This isn't going to end up on a drawing either. These are just control parts that are how I'm manipulating how my other parts are. So these are kind of just control files. This was the first assembly. That's why I save this with the surfaces turned on so I can identify what it is. And this is pretty easily identifiable of what it is. And this one here is the first one that just looks like a normal assembly. And it is a normal assembly. It will have these parts that I can detail. And then I've got to make sheets for all of these too. So what I've got is I've got this sheet is my sheet one of where the assembly is, and I'll bring in a parts list for this. I can bring in a parts list right now. If I just go to my annotate and bring in my parts list, it wants me to select a document. It's going to be the IAM file right here. I'm going to say OK. Let it create a BOM view. So this is all that's in the assembly right now are these parts, right? They don't have a description. We need to probably update the descriptions on them. Um, but those are the three different parts that I could put a balloon on right here to call them out. And if they had a description, the description would just be probably 12 gauge stainless steel, just what the material is. Or it could be a description that says it's discharge chute, or it's yeah, but I'd probably just actually put the material that it is in this particular assembly parts description. I also need to fill out a description for what this is. So I've got some I properties to work out here, but and we'll work through those. I mean, those are just it's kind of depends on how you like to organize your drawing sequence. For me, I like to get stuff on here and then I'll start to massage through everything and go through my sheets, make sure their parts lists are correct, make sure my view labels are correct. So that's kind of once I'm kind of getting deeper into my drawings. Right now, I'm just creating a space for these things to live. Yeah, so that's that one. Um, and then my second sheet, I put it on there again. It's because this is going to become a dimensioned out sheet, really. This is going to have some linear dimensions. I'm not going to rethrow the isometric view of it. I just want to detail out some linear dimensions. So this is going to become a dimensioned sheet. I think it's still a little bit big. I think I've got to edit this down to probably a 10th scale here. 1/10 is going to allow me to actually apply some dimensions here. It's a pretty simple print there. I mean, I might be able to fit more on this print than just this one single part. Not necessarily though. I don't because this is going to grow out a little bit. So I've got to think of like keeping space. So I think I'm just going to leave that one like that. It's going to be where I start to dimension linearly with my orthographic views. And this first sheet is just for parts identification and for maybe some sub-assembly identification. Mostly this is just going to be ballooned out with no dimensions on it, just an identification sheet. This one is going to be starting to be a dimensionable sheet, dimensions that I can watch as I would build this assembly out. And then I'm going to go down to one more sheet and start placing those individual parts on here. So now I'm going to come into here. This is my third sheet down, and I haven't chosen to name them yet because I just don't know what I'm gonna, I'm kind of into this free flow, this free exploration stage of my prints. But what I'm going to have, but this is kind of how I would organize a print set, is I would say, here's an assembly, and maybe be calling out the subassembly parts or even some individual parts that show up in it. Great. And then I'm going to come down here and start detailing out the subassembly dimension wise. And maybe this is a subassembly eventually in some ways. And so I will start to add dimensions to this. But then I think of like, okay, now I'm going to break this down. The next step is to break it down part by part and dimension those out. And so on my third sheet down, now I'm thinking of that assembly. What are the parts that are in that assembly? And I need to bring those out, bring those in to detail them out. Well, they're the three parts that make it up. And I can fit multiple of them. I don't have to have a single sheet per part. I'm going to try to fill up my sheets. And so I'm going to say, well, I need to bring in, so I want to place a base view of, and I have all my parts open and all my assemblies open. So I just need to be careful on which ones I pick, but I'm going to have, SC5 is going to come in for me. SC6 is going to come into the sheet as well, and maybe SC7. And whether they all fit or not, that's questionable, but we'll see. I'll start with SC5. For me, that's what mine is. It's this part. It's kind of the same view as that, but it's, it doesn't have all the other parts hooked to it. So this one is more, yeah. And do I need to have it both ways here? I don't know. I mean, it's going to be hard to fit this on those big linear, those big, if I'm putting these vertical views on, they're going to have to be potentially have to have some line breaks in them to fit. Unless I scale them down a lot, which I think I've determined that this thing fits better on like a 10th scale. But and I would add view labels to this as well. It might be that this part itself has to maybe come to its own print in order to detail it out correctly. And I need to leave room for probably like adding a detail view here and then exploding that up to define the flange dimensions. So this is, and add maybe a break line to this so that it'll fit on my sheet if I feel like if I need that top view. So this comes into our view selection again and what I need to define. I'm going to leave these on here even though that thing is like off my sheet. It just gives me a place to start detailing parts and to create detail views and potentially section views and break lines to, yeah. So we've got some work to do, but I know I need to detail that part out and all of its and all the dimensions that I got to be critical of with this part. That's going to come in. Maybe I can't fit too much more on that. So on my next sheet down, I definitely can fit the next two parts that are associated with that. And so I'm going to add these, which for me should be number 6 and number 7. This is number 6. And so I'm going to add its view label. I'm going to add maybe that and maybe a top view. And I'm definitely going to scale that thing up. That thing can get way bigger. 6th scale. Even bigger yet, probably, to detail this one out. Quarter scale. It's a pretty small part. I'll go with a quarter scale right now. Maybe I'll have to adjust that, but there's my part. And it's 3 views. Sometimes if I have room, I will add the isometric view to these, if it's helpful for sure. But this is just going to be where I can detail out dimensions of this part and how it needs to be formed, right? This is going to be kind of a detail sheet for that particular part, but it's got room. I can add more parts here. So I'm going to add another view. I'm going to add that other part that won't unfold on me now, unfortunately, but we'll get it to. Well, we will not be defeated. We will not surrender. Let's see here. But this one here is my discharge chute that's not operating exactly right for me, but maybe I'll drop its 3 views with a view label. And I'll consider adding isometric views as I work along, and I'll consider getting rid of views that I don't need. Once I start dimensioning, I think I told you early on in your drafting career, sometimes I will drop views on here. And then once I start dimensioning, if I realize that I didn't even need that view, it's not holding any dimensions, it's really not clarifying any visual stuff for me, I can just delete it. And so that might be the case here on this, that maybe, I don't know. I haven't determined that yet till I start dimensioning. So I'm just kind of giving myself some work to do here. So there's 2 parts on this sheet that are associated with that. This one is just a big part, so maybe I can't fit very much more. And I need detail shots of this as well. So I've got room to put details in. And then I've got this one that is going to be, as they all are built together, what dimensions are critical for them for me to know as I, assemble them together. And then here's going to be this main sheet that's going to definitely grow out from where we are. So I'm going to jump in and add some more parts to this assembly. But this is at least getting my sheet started. And then I've got to come back in and do names. And this name to me might be, the screw conveyor overall assembly. And then and that might become what my name and my title is. And then I come into here and I say housing assembly. And then I would come into this one and be like, this sheet is housing part, sheet one or housing parts. And then I might come into here and say housing parts. So I might have two sheets of housing parts. That's kind of the way I'm systematically breaking down how to detail this out on sheets is think of like a overall assembly and then a sub-assembly and then the parts associated with the sub-assembly. And guess what? We have one more sheet that I can add right now. The cut files for these parts. So on my fifth sheet down, I've got a lot of dimensioning to do for sure. But on my fifth sheet down I'm going to start to create a cut file sheet here. And so what I'm going to do here is let's add those parts, base views of those individual parts again, but in their flat pattern orientation. Which one is a jacked up one? But that's okay. I'll still place it and I'll hope to fix it. And but it might not necessarily. When I go to fix that flat pattern, I may have to delete that flat pattern a few times. And if you delete flat patterns, then you lose them on your sheets that you've placed them. So if I ever delete a flat pattern that's been attached to a sheet, I pretty much have to go back to that sheet and re-put the flat pattern on. So I mean so sometimes you have to do that a few times. Or if you think about it ahead of time, you might be like, I'm not ready to put that on a sheet yet because my flat pattern is still jacked up or something. But here I'll put it on there and we'll go through that process. So what it is like, yeah, I do want, I'll think of systematically a little bit like part five was my big housing part. And I want to display it on this particular sheet in its flat pattern orientation. It sizes that way down for me, like 1/20th. Just as a side note, I can mix scales on here, but be careful in CAD doing that, or be careful with DXF files. Some equipment will always like scale all parts to the first part that has been placed on the DXF or a cut file sheet. So you have to be careful knowing what like how the I think older machinery had a harder time at working with mixed scales on a same sheet. I think newer equipment it's not such an issue, but there are still legacy equipment that people use that they're really careful on not mixing scales on cut file sheets. And so, I mean, it's kind of a good practice just to prevent yourself is like pick a scale that kind of works for all your parts even if the parts seem pretty small, or sometimes too big. Like I don't know what scale is, but I might try to make the scale on all these the same. So this it's saying 1/20th here. Um, um, I think that's going to be really small on my other parts. And so I think I'm going to make this just a little bit bigger. I think like 1/10 is maybe a little too big, but not overly bad. Let me just go with a tenth here because there is detailing that needs to be done on this sheet as well. I got to put my bend details and just some overall dimensions so it can be a recognizable sheet from a palette of parts potentially. And I will add the view label to it. And so I'm going to say a tenth scale on mine. It's kind of a big flat pattern part. How do you make it not grayed out? Oh, if it's grayed out, it means it doesn't exist in your part. So if there's not an option to make a flat pattern, it's because on your part, you have not created a flat pattern potentially. Yep, identify a side and then create that flat pattern. Otherwise, you won't have that as a placeable. Yeah. And I'm generally checking these parts before I ever go to sheets because I know I'm going to make a flat pattern. I'm checking to make sure they unroll. I know I've got one part that still has an issue. It won't fold, it won't unfold for me. And so, yeah, it's kind of part of my process getting ready for sheets. There's that one, but I'm going to place like I fill up my sheets I'm going to probably make like a note up here that says 12 gauge or add that to the note down here. Potentially, I could have done some things before I made all those copies, and every one of them has a revision history. I'm going to delete those off. I just want my revision history on the first sheet of my set, which technically right now at this stage, I don't know what my first sheet is yet. I don't know if that assembly that I picked is going to become my first sheet. I'm kind of in the air on that a little bit still, but yeah, we'll eventually come down and strip off the revision histories because Yeah, my first revision zero will pretty much just have one revision block on the very first sheet. And then as revisions happen and they impact sheets, I start adding those revision blocks onto those specific sheets that they've been impacted. And my first revision history will always be the master list of all the revisions, right? And they'll even have a little description that says, see, this is on sheet 12. There's a revision. You go to sheet 12 and you'd see, oh yeah, there's a revision history thing that's been applied to that sheet, and maybe there's something bubbled or ballooned around it with a view label of what was been revised. So yeah, but right out the gate, I only really am going to have one revision history block on that first sheet. But I don't know what sheet that is. It's going to be one of my main sub-assemblies or my main overall assembly. And so with that in mind, so I'm going to add my other two flat patterns, even though one of them is jacked up. So that would be just like select a base view and make sure that you've created flat patterns for them. But like this one, number 6, has a flat pattern that I can place here. That's the same scale, 1/10. It's quite small, but that's okay. And it's only a single view. I'm not doing orthographic views of these. Think of these as just cut file sheets. They're just what the laser is going to interpret, or the plasma machine, or some cutting machine. So I still want a view label because that's how I know for my prefab people, they know that this part looks like this. And and I will have, I've got to do those bend details and bend notes. And then I'm going to place that next one that's jacked up. Just it has a placeholder. It'll probably end up deleting on me later, but I'll just place it to kind of know that I should have a flat pattern that works for this part that right now is corrupt on me. In fact, it won't even let me place it. Yeah, you're right, because it says, hey, I've got issues here. So maybe that's not so if this is the case, I really can't even place it because the flat pattern is if yours is working, go ahead and place it here. Mine still needs work, and so some of yours still do too, and we'll fix that later. So technically, I can't place that with a corrupt flat pattern. But if yours did work, place that on this sheet here for sure, just that one view. And then so I would have 3 parts on here. Eventually, I'm going to probably come name this, yeah, the 12 gauge cut file sheet. So, and I'm trying to think of them as being the same scale, just so if I have an old piece of equipment, the scale doesn't jack up the size of the part. That's what usually happens on old equipment. It's just like the first part that was placed on the sheet, it like applies that scale to all parts. And I've seen a whole nest be cut at the wrong scale, which is super like it makes you have a really sick feeling in your gut knowing you just cut a whole sheet of wrong parts and the sheet was several $1,000s or something. It's a simple mistake that is unfortunate, but like I said, new equipment doesn't seem to have that interpretation issue on scaling different. It'll just accept it as a one-to-one. Okay, so that's good. So it already shows you we're going to be dealing with a lot of sheets on a normal mechanical engineering project. And then I got to think of organizing them and naming them. But I just want to save this with all these, at least this started. Save it. Okay. So now I've got a sheet started. I've got a lot of work to do. Job security. So what I want to do in just the last few minutes, I'll make use of my time here, is just let's go back and let's create the 3/16 parts are quite easy. There's no bending or anything on those. So I think let's start a new little part assembly. So I'm going to start a new part here. I know I've got a lot of stuff open. I can start closing some stuff. I'm not really working with my solid right now. I'll keep this one open. I'll keep my main assembly open. I think I'm going to close the individual parts at this point here. I usually keep my drawings over to my left because I think of reading left to right, and I think of like my drawing is my master. Here's the assembly. That one I can probably close, and then there's that assembly. But I'm gonna have to get back in here and rework it after class anyway, so I'll leave it open. And there's that assembly. So let's start a new one, a new assembly, or sorry, a new part. Just make sure it's an English part, and it's gonna be a sheet metal part. Yep, yep. I'm gonna create it. I'm gonna derive in the solid again. So I'm going to derive in that same base solid. I think oh, I know. All I've done is open a new sheet metal part. That's all I've done. Yeah, yeah. Just open a new sheet metal part, make sure it's an English part. Yeah. New sheet metal part. And if you open a standard part, it's easy to convert it to a sheet metal part. And then I'm looking to add my solid into this one. So that's in my parts. Here is my part solid that I'm using as my solid two. Eventually, I'll probably move my solid one into the obsolete folder. I've created an obsolete folder here because I ended up having a couple redundant parts that I dropped into my obsolete folder here in my parts folder. But this is the S2 was the one that's really in that other part assembly. So I'm going to open that one as just this is a part. Yep, yep, yep. This is another controlling part that's going to have my surfaces and my solids underneath it. So I'm deriving in that. I'm still just bringing in the solid bodies as a surface. I'm not bringing in any sketches here, but just so you know what I'm going to do when I get to those 1/4 inch plate ones on the ends, I'm going to bring in like this sketch with it. Because so I'm just like I'm going to do the 3/16 inch parts now, which don't have any bends associated with them, but the 1/4 inch parts will have bends on them, and I'm going to need this sketch in those hole locations. So I'll be able to toggle on, like by just clicking through here, you can toggle on to bring in this sketch. That's if you know what you're going to do with it. If you end up bringing it in and not bringing that in, it's just a matter of you adjust what is going to be displayed from the derived part. So you always have access back to this dialog box if you don't select it right up front. But on the 1/4 inch part, I'm going to need these hole locations to add to my flange that I bend on here. I don't need them here because I'm not working with 1/4 inch. I'm thinking of working with the 3/16 because I think I can probably whip them out here pretty fast. So all I really am bringing in is the surfaces, the bodies as a surface, just essentially how it looked in the last time we used it. But what I'm thinking of now is, yeah, let's set up my sheet metal defaults. So this one is 3/16 inch plates, 3/16 inch stainless steel. So I'm going to go to my sheet metal defaults. And I'm going to set up a new one here, a new, and I'm going to just say this is 3/16, which I will use a actual. This is actually 3/16 inch. I'm gonna call it plate. We're gonna use plate, which I'm just gonna you can write all of plate, PLAT, 3/16 inch plate. I'm probably gonna put SS in front of this. That's gonna be stainless steel plate, 3/16 stainless steel plate. I'm gonna say okay. And then I just need to define what that is. So as far as the sheet, it's going to be stainless steel. Oh, not silver. That'd be cool though. Stainless steel. And then its thickness for 3/16. I'm going to put it in decimally. I think you could put it in fractionally as well, but it's 0.1875 is what 3/16 equals decimally. And then I think I'm going to go through and what we did on the other tab was I don't think I even want it to bend in the event that I'd ever bend this, which I'm not necessarily going to, but I think I'll keep the same 0.03 thousandths of the relief width there, just enough to separate if I ever have a situation like I did on that other. And then the corner, I think I will also put here. This one is one that I would say tear is maybe a little insufficient. Um, Maybe I'll just leave it trimmed to bend on that one, just for, and it's really not going to affect us on our particular parts right now anyway. So I'll just leave that as default and just set the bend relief at 3/1000, which also really won't affect us, but I'm trying to keeping systematic in my approach to these parts. And then I just want to use that one. That's the one I want to use, this thickness from this rule. And I think I can say cancel on this. So now I'm set up to be 3/16 inch. So now what we're gonna make here is this part, and this flange part here, and this part. So really I have like one, two, three, four parts I'm going to make. The only reason why I have one sketched here, sorry, right here. Well, I've lost myself now. Where are we at? The only reason why I've drawn one of these is because I think I can use that same part and just flip it like mirror. I don't even have to mirror the part to actually mirror it in use. Like I could mirror it in Inventor and say, well, mirror that as I create it. But really, I'm just going to use that same part twice. I'm just going to assemble it flipped. This is something you'll get better at too, is realizing when you need left and rights, and when you realize that I don't need them to be totally different, that the left will serve the right as long as I constrain it in there on the right. But this is something you get better at with time, is recognizing, mirrored parts, what will not mirror, what will not be able to be reversible per se, and that it does have to be independently left and right. These are concepts of parts that you'll get more familiar with. Right now, it might be a little abstract, but I'll make the easy one first, which is going to be this bottom flange here. So it's just going to be to me like making a sketch of that. If I create a new sketch, and I'm just going to make it on wherever you could choose this surface or this surface to make it from. I'll just choose the bottom surface for no real good reason. And then I'm just going to use projections only. No dimensions. No. I just want it to, if I ever update this solid, I would want it to accept those updates. And so by using projections, I eliminate uh, having to do any constraining or dimensions or anything. And then those projections should update automatically with an update to the solid underneath it. So unless I decide to delete stuff off the solid that these projections were from, that's when they become pink, as it's just totally lost its reference. They'll stay yellow as long as you don't delete and you're only just, you know, changing your solid systematically without deleting it as well. But I'm just going through here and I'm actually strategically choosing, not that it would matter which side of this hole I choose, but I do think if my sketch is on this surface, the hole that I'm projecting is on that surface. And that is the entire part for that one. I know we created, gotta get this inside edge here. So I've just done, this closed polygon. It's all projected. And then I'm going to finish that up and then just face that because I've set it that it's 3/16. So if I hit face here now, yeah, and I guess I could have used thicken as well, right? Like why I did this way, I don't know. But it is good to see that this is how a face works here, is that you have to have a sketch to drive it, like an extrusion. And then it just needs to know that profile. And then, but it's going to automatically apply the thickness that my sheet metal default is running. So I just need to go the other direction. I need it to fall right in the space of where it's supposed to live in the assembly, which is like that to me. So there is the part created like a face sketch. And I'm going to say okay on that one. And so that's that first solid in the mix there is that flange. And then let's do this again with I've got the inlet flange. Oh, this one here. Let's do this one. So I'm going to do a new sketch here. And this is going to be a new solid though. I don't want this to join to that other solid. So this is the same concept of, we've labored intensely over the 12 gauge one. This one should go a little quicker because it's kind of the same concept that I'm going to do a sketch here. And I'll pick this face just because it's not, if I pick this one, it's kind of gonna, I have to turn that off, but let's just pick this one because it's not buried. And then I'll say, no, I don't want to do a plane. Let me just do that again. Start this sketch here. Oh, good. Then it jumped into my sketch. I know it jumps around on you a lot, but I'm just going to do all projections of this particular 3/16 part, which is going to be like here, here. Oh, I'm doing this little side, this little hidden one on the side here. It's almost like a forgotten part, but not really. It's the flange that welds to the housing to accept the end plate is what it is. But I've only drawn half of it. There should be one on the other side, but it's because I'm going to reuse the part twice. So what I did is I just saved myself some design time on the solid itself because I could recognize early on that I was like, I only need one of these. I can reuse that part left or right. If Probably early on in your career, you wouldn't have realized that. You would have said like, "Oh, I think I need to make that." You would have maybe been tempted to draw it over here as well, because what it is, it's the mating flange to bolt the end plate on. The end plate is removable, and I discussed that early on. That's so the auger can come out of the ends. I could pull this auger out of either side because I have both of my end plates will be removable. That just gives you access to remove like as a maintenance or it's not even just maintenance. It has actually an assembly thing so the people can also sometimes the way people maintain and maintenance stuff is the same way people have to assemble it when they're actually building the parts. And so if you had just welded on end plates, I really can't slip that auger through that little 2-inch hole potentially to even get it in. So my end plates just are removable. I can bring in my auger and then I can slap on the end plates and bolt them up. And that's what I'm doing is this particular part is creating that mating flange for the end plate. Yo. Like you're not able to select these edges of your solid. Yeah, I am zooming in super close and making sure I can just get the projections that I It won't allow you to choose that edge. Right here, I selected this face here. Yeah, I've selected, yeah, because it wasn't sandwiched between this other one. I could turn off this surface so that I could get to that face, but just so I didn't have to turn off any surfaces, I actually chose my sketch faces right here, that face of that surface. Yeah, I can come take a look here. What you'll see me do, I'm just going to zip through this real quick just to finish off my video, and then I can come around. I'm going to say finish that one because all I'm doing is facing that now, and maybe you can see if I do something different on my next one. But there's my part that I'm trying to face. I need it to go that direction, and I'm going to say okay on that one. Oh wait, did I join that or not? I think it joined, so I need to make one correction on that. I need to make sure I'm making a new solid on that one as well. So I get that two different solids now. But let's see if I go over to this one. You should maybe have the same issue here because the U-shaped one is sandwiched against the end plate. And so what I did when I did the other side is I came in here, just try it over here and see if you can just leave that one standing for a minute and say, start a new sketch. What I did is I picked this face. Just make sure I'm on that face. And then it zips around. It moves me clear to the other end, but that is the face that I want to do. And so I'm in the sketch mode. I'm sketching on this face, and then I'm just going to start projecting this geometry. And I tend to like zoom in here, and I'm kind of picking the edges that are on that face. Like that's this edge, not this one. And over here, I'm zooming in. Yeah, I can zoom way in here, but I have no trouble selecting these. This is where you're having trouble selecting these. You can't select any of them. Yeah, maybe try it again on another on another part here. You can just kind of like abandon ship on the one you're working on and see if you can do a new one here on this U-shaped one. Because all I'm doing is chasing around this thing with all of its projections. Well, that's a problem too. I don't know. Like on the solid? Oh, I don't know, because I don't really have access in this case to what it's the one that lived. Do you have this one up here to test on? This flange? That one? Okay, we'll do that one in just a second. I'm going to finish this one. That's my entire that's my entire like U-shaped with hole patterns in it projection. I'm going to say finish that. And I'm going to say face that. This is maybe this I had to select that profile to face it and then select the solid. I want to make a new solid. And then I want to make sure it goes the right direction, which is right there. So it overlaps. I mean, that's what my surface features are. They just help me know that I'm facing the correct way. I'm watching that lineup happen. I'm like, oh yeah, that's right. That's where I'm expecting that part to be. I'm going to say, okay, it's my third solid. So I don't know. Try if you have this one drawn, let's try it up here. It's just a matter of defining a sketch face, which you could choose this one in here, or you could choose this one out here. I'm probably just going to choose this one out of ease, but I could choose to sketch this one here. So I'm going to say start my sketch, pick your face of your sketch. Mine's going to be, this face right here. It flies around crazy. It always does that. It seems like it goes back to like the origin point. But then I have to remember that which face I'm on is right here. Kind of get this. You can change construction lines to solid lines. This is Yeah, and I'm going through and individually picking them. You could probably like there's other ways to project. I'm kind of like slow when it comes to that, just so I'm kind of slow and critical, but you could probably like project cut edges, like we'll slap on stuff pretty fast. That's pretty good. I mean, it got me more than I want. Like I could delete these ones out that I don't want, but you can play with different ways to project. I think cut edges is a quick way to do that. I'm a little bit like I guess I'm a little bit more I'm just kind of careful when I do some of this stuff, but yeah, that would work great. I'm just individually selecting my geometry a little more manual, But select cut edges, I think, is a fast way to apply, and then just delete out what you didn't want that may be. But I'm okay with this being just a little more manual because I think it's just kind of a learning process anyway of what's coming in. And sometimes if you're not careful when you project cut edges, you might be getting just some other polygons that you really didn't mean to get or you don't want, and recognizing those. This is kind of like almost like tracing in some way, like, oh yeah, I'm just very carefully picking the edges that I want as I roll around here. There's that one. Yeah. Yeah, you got to be good with your 3D mouse to do this. Look at me. I can just like go to town. You got to be able to get in there, get all. That's why, I mean, I can't even drive with a keyboard. I tell you, I'm like handicapped with a keyboard. I am a total 3D mouse junkie. So, oh, I think I'm even gonna buy one for mine. Actually, I stole one. That would be a pretty good prize, actually. A 3D mouse. No, but I was trying to get some like separate monitors for prizes as well. Like I think a lot of people don't have like their just like a. I think they make just like a screen to plug into a laptop for a second. I think those would be good prizes. 3D mice. Yeah, yeah. We always do like storage drives. That's always one. In fact, we only did storage drives last year. But then we give you a receipt because one kid won. He was a high school student. He won. I think he won something. He was placed in the race, I believe, and he chose to go get a Lego set with his. So usually we give you the receipt for whatever we get you, and you can take it back and just like cash in. Or yeah, he bought like a $100 Lego set. I was like, oh sweet. That's pretty sad. That's not even fair, is it? And we had fewer people last year, so we have more people this year. So maybe that's less likely to happen, but they should have done the right thing and give someone else their. So I'm going to face this, and I can come around, or we can catch up on. I'm going to make this a new solid as well. It goes this way. Well, oh yeah, it's 0.1875 because that is, and I set that in my sheet metal defaults, right? Like that's yeah, yeah. You lost that. Yeah, yeah. That's all good. That's all good. These technically are all of my 3/16 parts. So I know I'm a little bit over time, but I'm really anxious to send these to that assembly. And so I'm going to do that really quick. And I'm still recording, by the way. It's a really long video, by the way. Sorry. I've recorded, and it was really a silent start for about 30 minutes as I was troubleshooting my flat pattern. So, yeah, and I still have that to work on. So really, you can fast forward through 30 minutes of this one for sure. And but what I want to do is just I know you maybe not everybody's here, but I can help you if you can stay, or I can definitely help you tomorrow if you want to come in, or I can help you early Monday, or yeah, because Monday I don't know what we'll work on, but I definitely can help get us to this point because what it is I've got all these parts. There are four different solids, one, two, three, four, that were 3/16 plate. Now this is what's cool about this. I just go to make components. Oh, I haven't even saved anything yet, so it doesn't even know what this is. So I'll say, no, I got to save this first. Save should make me, this is a part itself. So I'm just going to name it the next part in my sequence. So I'm going to go to my part folder. Um, it's just going to be SC008 for me. That's my next part in my sequence, which I usually select this and then just quickly change to 8. It's just the next one in my part. It's not. It'll be one that I also leave the surfaces on so I can see that it's kind of this weird like part file that has multiple parts in it. It's what I like to call that part assembly concept. And I'm going to say save it here. It still lives in my part folders though. It's going to be the source of creation for these. So, and then I'm just going to say make components now. But the thing is I have that target assembly. Um, it, and so it's going to want to rename it as probably to match my name that I just chose. But I'm going to say, no, I want to choose a target assembly. And says, do you want to create a new target assembly? A lot of times that's yes, and this time it's no. I want to choose a target assembly. And so I'm kind of outside my parameter because I drove out and it lost. Where am I? It's going to be the only assembly I still have. So it's like in my assembly folder. Wrong one. This one here. My assembly folder just has that one. This is my target assembly. I want to send these 3/16 parts to that same assembly. So here they go. That's it. Yep, that's what I want. Open it. That's now my target for these parts. Now I got to select the parts to send to it. And so it's this one. Solid one. It's going to be solid two. Ooh, it shows that as a surface. I'm going to quickly turn off. I don't want this one. I think I can remove that from the list. Delete it. Remove from selection, that one right there. And so maybe I'll save myself a little trouble here and I'll turn off my surfaces because it's going to want to select those. Actually, whoa, 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 whoa. That's not what I want to do. Back up the truck. Sorry, I aborted that. I left that. I'm gonna turn those all off just so I don't accidentally select a surface. Make components. Let's find my target assembly again. No existing target. There's that one right there. That's the one I want. Now I can choose my parts a little easier. I need this part. Of course, I still haven't done the nice thing about naming all these specific names, but that's okay. They're just going to be solids. Those are all my parts. Going to that target name, I'm going to say next. Now I've got to give these all a unique name and choose their paths. So once I set, it's already preloaded the last place I sent. I think there's a lot of like it remembers the last time you used this where you were sending them. So it's the same folder on these. I'm sending them all to that to the parts folder. So it's kind of a quick selection here. And then they're all sheet metal templates. I just need to start naming them the new unique name. So that's usually when I come and reference my folder and say, oh, I'm up to part 8. So I'll just call this like 9, 10, 11, and 12 in that assembly. So, and I think I can just probably copy paste these unless that causes me a problem, but maybe I'll just name one ISU dash MR for me dash SC 009 was the next one in my sequence. I might just do a quick like control copy of that, see if I can just copy paste these now. Yeah, I'm gonna just paste that one in, but change it to number 10. Hey, we're up to number 10. And then I'm going to copy paste this one 9, 10, 11, and number 12 here. 9, 10, 11, and 12. They're sheet metal parts, normal bomb structures. They're going to that location. I'm just using a targeted assembly already. So I'm going to say OK on this now or apply. I usually say OK. It went to that assembly and it applied those parts to it. So there's no like grounding and rooting. There's no like constraining. However, I'm not totally done because it only sent one of these in there and I need two of these. So this is how you do this. And you can kind of recognize how it's like constrained a little bit. Yeah, it's like flush to the end here. And it's kind of up against that side. So what I'm going to do is this is how you can add a part. On your list, you already have all these parts. There's that one. It's SC10 for me. Might not be that for you, but all you do is like drag and drop this. Click it, drag and drop. It drops in that part just like that. And then what we can do is kind of orient it to how it goes here. This is why I didn't draw two of those, is because this thing is kind of reversible. Like as long as I hit like the keyboard G is how I spin these things, right? Like G is how I kind of free rotate. That is one keyboard stroke that I use quite a bit. F7 to slice graphics. Hit keyboard G and then select it, and it brings up that little telescope here. And then I can actually just rotate these parts into how I might need them. And then I've got to do some constraints. So all I did is I needed to rotate that around. I didn't want to flip it upside down. I think we're pretty well symmetrical from where the whole pattern is from the ends, but I definitely want to keep it like top is top. And then I'm actually going to do my normal constraints that I would do in an assembly that we've done before. So I'm going to go to my constraint tab and say, well, I know that this piece goes up against that piece, but it's actually got a 30 thousandths clearance actually. And that was just so it slips over pretty easy. And it kind of matched the clearance that I was creating. So I'm going to say that I want to say this face is going to attach to this face, either this face or this face. They're in the same plane. So I'm going to slap that thing on there, but I'm going to go ahead and put my 0.03 clearance away here. And I'm just going to zoom in and make sure it's going away and not towards it. If it's going the other way, add a negative in front of it and it'll be going the other way. But I'm going to say apply that one. I want that to be in that position. And then maybe I'll say I want this face to be on plane with this face. like that. That's one way to do it. I'm kind of driving it from the position of that other flange. And I'm going to say okay or apply on that one. They seem to be in the same plane. If they're not, try your different solutions. This is the solution I want. Apply it. And I'm just going to do top. I'm going to do a top plane constraint to this one here. So I'm kind of using, yeah, I'm using that nice ground and rooted position. If that one isn't work, I'm going to choose the other selection. Ah, that was it. And apply that. So now I've really just, I've got an issue there on that one though. I've got to reverse one of these constraints on this. So I'm going to open up its constraints. That's the 30 thousandths. This mate, I think I may need to reselect the face that I'm flushing up here. So I'm going to come into this, edit this constraint here. I'm going to say, well, I see why it lined up the way it did. I had selected that face and it's that face. So I'm going to do a new face selection here. I'm going to select this face. And maybe it has to go that way. Yes. And then just make sure that, you got to make sure when you're doing something like this, you've got to make sure that you've oriented it correctly. And that you haven't pushed those holes are not centered on the plate. So it's not reversible in some ways, but it is kind of flippable. Yeah. And so that's it. That becomes I'm gonna save this one really quick before I leave it. It's gonna save everything downstream from it. Those will also need flat patterns, even though they have no bending going on. They're just going to be a cut sheet. And so I will go into that part, make a flat pattern, and then start like a 3/16 cut file sheet as well. And on my cut file sheets, I will mix and match materials as long as I kind of like draw some sketching and separate them, and then maybe add a local node above and say this is 12 gauge stainless steel. You could try to help out your people reading your prints so they, but it doesn't mean every sheet has to have every cut file sheet has to only be one material. I mean, if I have enough parts, I usually do organize them that way. But if I don't have a ton of parts, then I try to bundle my sheets and fill them up. But this is that. So now I'm going to go back to my drawing and just watch how it updates all this stuff here. They all need updates, anything associated with that. Maybe I'll go back to this, the original sheet here, and I'll just hit update. And then you can see that it's starting to add those it's repopulating my parts list with more parts. And really all I'm trying to do, this is my end of my video, end of my week for sure. Next week we can get in. We got a lot of work to do. We got more sheets to create for 3/16. And I've got a part to fix. By Monday, I'll have my solution on how to get that stupid discharge part to unfold for me correctly and see if anybody else is, and try to help everybody on that one. And I might if I mess with that tomorrow, I'll make a video for it, maybe upload it. But then I'll discuss it on Monday, what I did for sure. But this is where we're headed. And so, yeah, if I jump over to my next, it's also accepting some of those new parts on it. Doesn't affect these because those are individual parts, so nothing's really changed on those. Just these first couple sheets have new 3/16 parts coming in their way. And I may choose to, yeah, I may choose to put the end plates on this and call this the housing subassembly. And then I still may have a subassembly ahead of this in the drawing that's going to have the inlet, the hopper on it and the discharge squared around, and maybe even the motor, gearbox, and auger and all that stuff. There's going to be, I feel like at one point there's going to be sheets ahead of this. And this particular first sheet in my set right now is probably going to be kind of complete once I put the end plates on it, and maybe some stiffeners along we maybe need to add some supports along this 8 foot span to kind of hold that U shape of my conveyor, because sheet metal is flimsy. And I've talked about how you can bend in sheet metal to create stiffening reasons. I can also add some external, like just sheet or some 3/16 like U-shaped parts that will become, stiffeners is what we would call that, along this long ways from inlet to discharge. Like the inlet and discharge are going to be pretty well, by the time we bolt on the end plates, they're going to be a pretty rigid structure. But between inlet to discharge and filling it full of potato and having some compressive force on these sides of 12 gauge, if I just put some U-shaped kind of ribs, they help maintain the integrity of the sheet metal from inlet to discharge. And they give me a place to apply some like mounts to maybe mount this to the ground or something. So I can kind of use those ribs and stiffeners to bolt maybe feet that need. I'm gonna have to hold this conveyor up somehow. So yeah, a lot of work to do. It's funny how long it takes. What's funny is once you kind of spend a lot of time on solids and those part models and how things fit together, really it's kind of like front loading heavy, but then the process of going downstream from there is relatively quick. And that's the idea that I really found the most valuable using Inventor is, you spend all your time front loading solids and part assemblies, and then the output from those it just happens. And so anyway, yeah. And where you find that in an inventor book, I don't know. But I just know I found it in the industry. So yeah. And what I figured, I learned from smart people. Like I was like, dang, that's smart. I should use that concept. But I also worked with people that were like, nope, I build my parts individually. And then you're like, well, every time you do an update, you got to go in and update that next part that's affected by it, and that one. And it gets hard to keep all that straight. And I like this automatic uh, functionality of Inventor. I tend to lean on it pretty heavily, and it bites you in the butt sometimes for sure. But end of story. You guys have a good weekend. If I don't see you tomorrow, if I do, we'll hang out tomorrow too.
You may or may not see it tomorrow. We'll see how I feel, honestly.
That sounds good.
I have a chain of problems, I think, preventing me from doing the last. But I think it all starts back with, for some reason, I cannot say